Hi, I'm Paul Lacey with Power Integrations. I'm excited to introduce you to CAPZero, our revolutionary new IC that completely eliminates the power dissipated by X-capacitor discharge resistors. CAPZero is a self-contained two-terminal device that can be added to any power supply with X-capacitor discharge resistors to decrease no-load consumption and provide more standby power. It's a beautifully simple product that easily meets safety requirements. CAPZero completely eliminates power loss in the discharge resistors, making it an important tool in achieving the lowest possible no-load input power. Reducing this wasted power is essential for designers around the world trying to meet upcoming EUP Lot 6 specs and ever more demanding no-load input power requirements. X-capacitors are used in power supplies to filter differential mode EMI noise. They sit right across the input terminals of the product and, as you can see here, will store energy for long periods of time after the AC is removed. To prevent this from happening, resistors are added to meet safety agency requirements that the capacitor be discharged with a time constant of 1 second. Without discharge resistors, energy stored on the X capacitor would be present across the input prongs of the power converter and could shock the consumer after unplugging the supply. But these resistors produce a constant power loss while the AC is connected and are a significant contributor to the overall no-load input power losses. CAPZero solves this problem by acting as a smart switch when placed in series with these discharge resistors. The switch is open while the AC is connected, eliminating the constant power loss to the discharge resistors. When the AC is disconnected, the switch is automatically closed and the X capacitor is safely discharged through the resistors. To demonstrate how well it works, I've constructed the input stage of a switching power supply on a small board. This board has been fitted with a 2.2 microfarad capacitor, discharge resistors sized for a time constant of 970 milliseconds, and a CAPZero device. I've also installed a test switch that can bypass or disable the CAPZero. First, let's look at a board with just a 2.2 microfarad capacitor and discharge resistors. When I apply 230 volts AC to the input, we measure an input power of 150 milliwatts, which is both the power burned by the resistors as well as the power lost through the input cables. After I remove the discharge resistors, we measure 40.52 volt amps of reactive power drawn by the capacitor. This current causes a 29 milliwatt drop in the input cables, which is measured as real power by the wattmeter but is not consumed by the circuit. Going back to our CAPZero board, with 230 volts AC applied and CAPZero disabled, we read an input power of 152 milliwatts on our wattmeter. Removing the discharge resistors, we see the input power fall to 29 milliwatts lost in the cables. That's 123 milliwatts of power burned in the resistors. CAPZero safely eliminates this wasted power. When I reinstall the discharge resistors, and then enable CAPZero, we see the input power fall by 118 milliwatts, just as if the resistors had been removed. Next, let's monitor the voltage across the input terminals of the board using a differential oscilloscope probe. With the CAPZero again disabled, we'll turn off the AC input and see that the voltage across the input terminals falls as the X capacitor is discharged. We measure a discharge time constant of 946 milliseconds. After enabling CAPZero, let's again turn off the AC input. Notice that the circuit behaves exactly the same as it did before. The X capacitor is again discharged as soon as the AC is removed, with a discharge time constant of 963 milliseconds. CAPZero has eliminated the power loss through the discharge resistors without affecting performance. CAPZero's high voltage rating gives it excellent surge characteristics and makes it extremely robust. The configuration of CAPZero in series with the discharge resistors gives it great surge suppression. It easily handles differential mode line surges of 2 kV. After completing the full set of testing required by IEC 61000-4-5, CAPZero is completely unaffected. Because CAPZero is a two-terminal device with no ground connection, it's completely immune to common mode line surges. With dual bond out pins on each side, CAPZero meets single-point failure requirements if a pin is lifted in a safety test or disconnected by a cold solder joint. The standard single-point failure of the discharge resistors remains unchanged, and even if the CAPZero is shorted out, the supply will still comply with safety requirements. CAPZero easily retrofits into an existing design to provide instant no-load power savings. It can be designed in using a simple lookup table and is scalable for designs using up to 5 microfarads of X capacitance. CAPZero devices are rated by the size of X capacitor they're designed to serve and by maximum voltage. You can select a voltage rating of 825 volts for a 1 kV surge withstand or 1000 volts for applications with higher surge requirements. Our table also provides recommended discharge resistor values for a time constant of 750 milliseconds. CAPZero allows you to use this increased safety margin without the associated increase in no-load losses. The only change necessary to add a CAPZero in this design is a small change to the PCB layout. The ease of design with CAPZero allows very fast time to market for updated green power supplies. CAPZero also provides design flexibility in the EMI filter, allowing you to use a larger X capacitor without having to worry about the increased power dissipated through the discharge resistors. Using a larger X capacitor allows you to optimize inductive elements of the EMI filter to reduce size and cost. CAPZero is a groundbreaking new solution for designers looking to reduce no-load input power consumption in order to meet challenging energy efficiency specifications. It's simple to design in, can be retrofitted into any design, and provides instant power savings. For more information, including datasheets, design examples, and training courses, please visit the CAPZero page on the Power Integrations website.